Okay, and this is the last episode of this series of videos on reliability analysis. In this part of the video, I would like to demonstrate how to do a quick Cronbach alpha analysis as well as McDonald's omega. Okay, as you can see, I have a number of items here. Each of them actually represents one total test score. These are not raw scores coming from one test item, but since it's just a demonstration of how to compute Cronbach alpha and McDonald's omega in Jamovi, it should be fine. Okay, so the items are grammar, vocabulary, comprehension, and so on. And the analysis that I am conducting here is to do to compute Cronbach alpha, McDonald's omega, and on this side I have item statistics. For example, Cronbach alpha if the item is deleted, and if McDonald's omega if the item is deleted as well. I've also asked for mean, and if you like, you can throw in standard deviation and item rest, meaning the correlation between the item and the entire set of the items that's other items summed up, the correlation between the two. And if you like, you can save the mean scores and sum scores, but I'm not interested in doing that in this demonstration. The most important thing for me is just this. And I also highly suggest that you click this additional option, which gives you a correlation map, because it gives you an idea how correlated these items are. If you recall from the previous videos, I said that correlation is a very, very important concept when it comes to Cronbach alpha analysis. So I suggest that you take correlation map seriously, as well as the statistics. Correlation statistics seriously. Now the output has been populated. The Cronbach alpha value is 0.85, whereas the McDonald's omega is 0.92. I'm not surprised by this because some of these items or these constructs, let's say, are not closely related to each other. So there is some level of multidimensionality if you really run a factor analysis on these items. That's why Cronbach alpha is lower, because multidimensionality, as you recall, can affect Cronbach alpha value, can reduce it, and therefore the effect is adverse. But McDonald's omega is not as sensitive as Cronbach alpha to the idea of multidimensionality. Specifically, even if we assume that the entire items are unidimensional, that is, they make one monolithic dimension which cannot be separated into several subdimensions, the advantage of McDonald's omega is that it does not assume tau equivalence. So since tau is not equivalent most likely in these items, if you run, for example, a factor analysis, Cronbach alpha may kind of fail to present a very precise image of internal consistency of these data scores. Therefore, personally, at this point, and without doing any further analysis, I assume that McDonald's omega might give me a better and more credible indication of internal consistency of this set of measures. When it comes to item reliability statistics, I would also love to look at items, if item dropped Cronbach alpha, if item dropped McDonald's omega, meaning what happens to these two statistics if you drop any of the items. If you go through these, and if we find that if you drop an item, your Cronbach alpha, your McDonald's omega increases, that might be some reason for removing that item anyway. For example, if I remove item SWTF, Cronbach alpha will drop, but interestingly, your McDonald's omega will increase just a little bit. Not a bad idea to drop it if you think that it doesn't add too much to the entire measurement. But if you feel that it is still important to keep it, especially in the interest of construct validity of your instrument, I would suggest that in these situations you would want to keep these items, because dropping them does not increase your reliability statistic remarkably. It's just a very small increment from this omega to this omega. Therefore, I would just keep this item. Another output that I would look at is this correlation heat map. The correlation heat map is a very useful indication of how these items are related to each other. And if you look at this heat map, and if you find any correlation that is especially close to zero or is negative, definitely you need to either reverse code it if it's a survey, or you just need to remove it from your analysis. Negative correlations are detrimental to the integrity of Cronbach's alpha as well as McDonald's omega. Let me see if I can get just really randomly, and I haven't done this before, any correlation which might be negative. For example, I randomly throw in this item. I don't think it will be negative, but still, let's see what we will get from the analysis. Okay, it's taken some time, and there we are. As you can see, it's not negative, but the correlation statistics here are quite low. It's 0.11, 0.14, 0.14, and let's see what happened to McDonald's omega. As you can see, it has dropped from 0.927 to 0.918. That's why we would want to look at the correlation heat map, or just the correlation metrics, to see if there's any item to remove. Another interesting way of looking at the data and deciding whether it's a good idea to remove the item that is in the analysis or not is this item test correlation, or item rest correlation. As you can see, the correlation between all of these measures and the rest are rather high. All of them are definitely above 0.5, which is fine. But when you come to the last item that I randomly selected, the correlation dropped to 0.338. And this is not a good indication if you compare it with the rest of it. So it seems that this item itself is tapping into a different thing. It could be a different dimension or anything else that is not really very much coherent with the rest of the measures that we have on the list here. Therefore, what would I do? I would remove this one, because now I have enough evidence that this item is not working in alignment with the rest of the items, especially with these low correlations, low correlations with SW total, SWL, SWTF. I would just drop it. And even this one is slightly lower than the rest of the correlations that you can see on this map, which is 0.22 and even 0.24, just comparatively. So there's rather convincing evidence that we will do well if we remove this item from our analysis, and let's do that. Okay, I'm going to remove this, and Jamovi will automatically re-estimate the reliability statistics, as well as it will populate these tables. And of course, it's taking its time. Well, my computer is a bit slow today, but hopefully it will be estimated. At any rate, this is how we estimate Cronbach's alpha and McDonald's omega, and we make sense of the output and make sure that everything that is included in the analysis is in alignment with the rest of the items there. Okay, so I don't think that this will converge today, because, like I said, my computer is slow today. Well, I can call it a day. Thank you very much for your attention, and I hope, oh yeah, it converged finally. I hope you found this video useful. If you did, give it a like and feel free to circulate the link of the video among your friends and network. Have a great day.